Good morning, everyone. Super excited to be here today at the very first Data Orchestration Summit. And thank you all for coming to this event. And hopefully you have a great day, having fun, and learn something from all the exciting presentations through the day. So my topic is that I want to share is about orchestrating a data symphony. So I'll explain what does it mean. But we are in the data era. So the most valuable companies today, they're all data-driven, rely on data infrastructure. And the logos you see, they're the top 8 most valuable companies in the world today. So as we all know, all the organizations, they are racing to create a data-driven culture. And they are trying to build as successful as possible data infrastructure and enable as much as possible from the data-driven perspective, data-driven application perspective. And beyond that, you can see we have so many exciting advancements in the world, like, for example, autonomous driving, like AI, like genomics, space exploration. They have one thing in common. They are all data-driven, and they rely on data infrastructure to drive those innovations. So these exciting technology and industry frontiers, and this exciting technology and industry frontiers, and in the end of the day, they want to build on top of great data infrastructure, and they rely on the data infrastructure to make it possible. So with this exciting advancement, and we want to ask ourselves, how can we get the value from the data? And it sounds pretty simple. In the end of the day, the organizations, they will collect and store the data somewhere, and then they have a data application written by innovative creators inside the company, and process and consume the data, then produce value. It sounds so simple and easy, and it's not a problem at all. And if that's the case, we just go home and be happy. However, in reality, it is not the case. And the people in the audience today, where all the people building the data infrastructure or using the data infrastructure and creating the future, we all know that building the right data infrastructure is very hard and is very challenging as well. And the question is, why is that? Why this is hard and challenging? What challenges we are facing? And if and how we can resolve that challenges? That's the question we want to ask. To answer that question, let's first examine what's our landscape and what's our ecosystem. So we are living in a very fast-moving world, and at the same time, with excitement, with development in our space, we're a very fast-moving ecosystem. So I want to talk about it from 3 different technology categories. The first category is about the compute. So we have explosion of the compute frameworks. And the reason behind that is that every 3 to 5 years, you will see new type of workloads coming up, drive the creation of new set of computation frameworks. And there will be many of them. And along the way, 1 or 2 computation frameworks will win the market and dominate the particular workload. And most people, you just use those for those type of workloads. And we all see, for example, like Apache Spark has won the ETL market. Like Presto is winning the interactive large-scale OLAP workloads. Very exciting. And in the machine learning, deep learning field, we're seeing like TensorFlow and PyTorch, they're competing head-to-head, but they're ahead of other frameworks. That's the computation side. That's what we have seen today. And moving forward, we'll continue to see every 3 to 5 years, there's a new set of framework coming up, and for the new set of workloads. And very possibly, the cycle will be even shorter than 3 to 5 years along the way. So the second category is about the storage. So storage industry for the past 40 years has been repeating one cycle. The cycle is that every 8 to 10 years, you are seeing a new generation of storage systems. They come up, and they are disrupting the previous generation. And typically, it's simple, it's easier to use, it's cheaper, it's faster. And the reason behind that, there are 3 dimensions cause that cycle and the innovation. Is hardware advancement, and architecture advancement, and new workloads. That's behind the scene what's happening. So with this, for most people in the audience, we have all observed or experienced the last cycle. So around 10 years ago, that was the rise of the HDFS, or HDFS-like architecture. And we're seeing that was taking the world, disrupting previous generation. But today, it is very clear to us, HDFS, or that type of architecture, is dying. And we're seeing the rise of the object store. And for example, no matter it's on-premise environment or even the cloud environment, people are choosing object stores. And even inside the HDFS community, they are proposing object store as a solution as well. And all the cloud vendors, their major storage solution, they're all based on object store. That's the second category. And the third category I want to talk about is the cloud, the rise of the cloud. So this is a big change. There's a big shift. And we can see from the SMB small companies, typically they can choose a single cloud as their solution to build their data infrastructure. But for the larger company, like enterprise, etc., they typically are going to the cloud from the hybrid cloud environment because they want to keep the data on-premise in many cases, and with the long-term strategy of the multi-cloud in mind. That's our fast-moving landscape and how the ecosystem has evolved. So with that, we are living in such an exciting era, and so many data applications are being created. Our life is changing. They come with lots of opportunities. And we have this fast-moving landscape for the data world as well. And in this fast-moving landscape, 3 categories, you come with so many challenges associated with each category. So for example, associated with the computation side, because every big type of workloads, they are winning frameworks. So inside the companies, people are asking, oh, we have Spark today. Can we add Presto into the picture? Can we add TensorFlow into the picture? How can we support that with our data infrastructure? That's one side of the question. I'm sure most of you guys have heard or in the discussion with your colleagues. The second side of the category would be, oh, I have data all over the place. I already have my data in different HDFS clusters. How can I move my data into the cloud? How can I use object stores internally because it's cheaper and easier to use? And the second type of category, and how can you orchestrate this data among the different storage systems and serve them to the compute? And then the other type of questions people are asking, how do we modernize our architecture? How do we move our data infrastructure into the cloud and leverage the elasticity in the cloud? For example, for my model training, it consumes lots of resources, and our on-premise environment has a fixed amount of resource. And can I just run that in the cloud? And we all heard these questions, and the answer is no, you cannot simply run in the cloud. In the data there as well, into your application to consume the data, there's a lot of work to be done outside of the building the application logic itself, outside of inventing on the algorithm itself. So in fact, like 4 years ago, Google published a paper. In the paper, it says that at Google, for most AI and machine learning engineers, they spend less than 20% of their time on the real logic, the algorithm, and the application itself. And they spend majority of the time thinking about doing provision the cluster, moving the data, or ask other people to help moving the data, ETL it, and prepare the data, just in order to consume it. So that's the reality today, and that's a challenge we are all facing today. So to further understand it, we take a individual organization perspective and see how individual company typically evolve their data infrastructure from the beginning. So at the beginning, they have HDFS, they have Hive, and they run some slow queries on the big data. And remember, before this time, you couldn't even handle that type of workloads. And then gradually, they learned there's a new framework, Spark, very fast, and then they provision HDFS with Spark. Copy data, have a data silo. And then now you have TensorFlow. and you want to process it as well, and typically TensorFlow talk with POSIX API, and you want to use NFS. You have to migrate the data from one HDFS to NFS, etc., and create another data silo. And typically, they are processing similar type of data set. And now, more fun part come into the picture, and you want to use a cloud environment. And in the cloud environment, you provision, like, say, AWS, and you move some of the data into the S3, and you start some processing there. And similarly, you have other clouds, and in other clouds, like Google, like Microsoft, in other clouds, sometimes you want to use the cloud storage, and sometimes you just want to use the on-premise data you have today. And you have to shift the data across the WAN, which is very inefficient. And you can see in this is already a very simplified version of all the data infrastructure in these big companies. And you can see how messy it is. So it is very complex, it is error-prone, and it's very time-consuming to build this type of infrastructure as well as leverage infrastructure. And because of this, you hear all those challenges, as well as that your application developers, in the end of the day, has to bother you, have to work together with you to spend most of the effort. Instead of building the application itself, spend the most effort preparing the data, managing the data. So instead of Symphony, it's become a chaos. That's a reality today. So with that reality, our question is that, can we build a future that we have a beautiful data infrastructure, we can orchestrate the data for the applications to consume easily. So we can return our time to the people to let them focus on the business logic, on the algorithm itself, instead of focusing on how to preparing the data, instead of focusing on, like, say, or asking, can I add another framework into the system? Just really make it simple and easy. That is our goal. So the question is that how do we achieve the goal? What can we do, right? So we're taking, we believe the industry is missing this data orchestration layer between the compute systems and the storage systems. And the reason is that in order to achieve the goal, there are three places you can do this. You either do in the compute side, but you know in the compute side, you always have the new innovation, another framework come up. You can also choose storage side, but you also know in the storage side, there's an 8 to 10-year cycle. There's so many solutions there as well. So then the approach we're taking is a data orchestration in the middle. So between the compute and the storage. So what it does is essentially it virtualizes the data from different type of storage deployments, different type of storage systems, and present the data, abstract the data, and present the data to all the applications, all the data applications, through the industry common API to achieve the goal so that applications, when they want to consume the data, they simply just interact with the data orchestration platform so that they can easily interact with the data from all over the place. It doesn't matter where it is stored and how it is stored. That is the goal. So that's the approach we're taking. It's actually very similar to like how our PC has evolved. So in our PC environment, we have a local file system. So as a user of the PC or the developer of the PC applications, you only see files and folders in your PC environment. So you never see what's behind the scene, which SSD, which HDD, what version of that, what spec of that, which NFS are you using. You never cared, you never gave a thought about it. So in the end of the day, you just consume the data and interact with the data. And the local file system in the PC environment, VFS, essentially orchestrate the local PC data environment. So we are doing the same thing or similar thing for a much larger scale for the cross-data center, cross-distributed system environment. So that's approach, the data orchestration approach. So just one level down, to build a data orchestration platform, what are some of the key requirements? There are 5 key requirements to have for this platform. Number one is a global namespace, and then intelligent caching, and data management, structured data catalog, and data transformation to solve the issue we just mentioned. So just go a little bit deeper into this about the global namespace. It's in the end of the day about abstracting the data and embracing the data silo, the fact of the data silo. You have multiple data lakes, and then enable the application using a unified way of interacting and accessing the data. That's a global namespace. And then with the fact now you can access the data, also the fact you have the data silo at different places, we embrace it instead of trying hard to break it. So this intelligent caching, in the end of the day, enable data locality for fast performance for large-scale data applications. And on top of this, you have data all over the place. You have data on your own object store, HDFS. You may want to transparently move your data into the cloud environment or another storage system moving forward. Do you want to do this manually? Or you have another requirements for the data orchestration system. You can seamlessly, this type of requirements can seamlessly migrate the data from one storage to another storage based on the requirements, based on the cost of the data and the cost of storage, as well as properties of the storage. Faster, cheaper, expensive, faster, slower, expensive, cheaper, etc. So that's a data management requirement. And beyond that, we talk about three first requirements. It's orthogonal to what type of data is serving. It could be raw data, and it could be structured data. But we all know in the world has so many structured data workloads, it's very important. So other two requirements would be like structured data catalog and data transformation. And in the end of the day, these two requirements help people to build more efficient, provide more efficient data service for the structured data, faster and easier to be consumed for your data, to be consumed by the applications. So that's the requirements we have today. And in many cases, in all these organizations, we're doing part of this anyway in our daily life. But we're doing this more in the like one or two property perspective. We build an ad hoc system and trying to solve one problem or the other. For example, we can do a lot of ETLs. We keep doing ETLs, moving from data from one storage to another, or migrating data from one storage to another. That's an example. So with the data orchestration platform, we believe it needs to have all these properties and to help people, to make the people who are building the data infrastructure's life much easier, and to make the people who are using the data infrastructure's life much simpler as well. So with the data orchestration system, how the platform could have looked like, or how we should build our platform moving forward. And this is an example. So at the beginning, you still have Hive and HDFS, and now you want to use Spark. You can simply put Spark on top of data orchestration system and use that system to orchestrate the data among different storage systems. You don't need to provision another storage anymore, and it'll handle for you, and hopefully handle ETL, all those things for you as well. And then now you have TensorFlow. Instead of like migrating the data from one storage to another one, now you have this data orchestration system co-located with your TensorFlow as well to orchestrate data for you, to enable data to be consumed by the TensorFlow applications easily. And now, similarly, you are running your applications in various clouds. You may use cloud storage, you may not use cloud storage, but in the end of the day, as long as your application talks with the data orchestration platform or system, that should handle how to move the data, make the data ready for your application, regardless how and where the data is stored. That's, with this system, how the future should look like, and how we are building the future for our data infrastructure. So at Alluxio, we have implemented open source version originally from UC Berkeley of the data orchestration system. And this is one implementation. So in our 0.1 release or 0.2 release, the first feature we had was intelligent caching. And then in our 1.0 release, the community made lots of progress. we released the global namespace. And in the 2.0 release, we start to have data management features as well. And later today, in the community leaders talk from Kelvin Jia and Bin Fan, so they will update you guys what are some new exciting developments in this open source community as well as open source software. And welcome you to attend that talk. And today, another thing I want to announce is that in our 2.1 release, we're releasing structured data service. And in Gene's talk later afternoon, you'll hear much more about it. But in a nutshell, to help you much easily for your SQL engine to consume the data. And the first example Gene will demonstrate will be the Presto with Alluxio with this structured data service to demo to you how he can use the service to speed up some of the applications from 20 seconds of query to be 3 seconds. And also, it's very easy to set up and use as well. And in the end of the day, to make this vision become true, to enable us to orchestrate data for the applications, to make the data easily consumed, to realize this data orchestration vision. So it's not one community's effort. In fact, we need to work with many different opportunities, and many communities need to work together towards this goal. And we are working with all these different communities are working together, like working closely. And in fact, many of these communities are represented here today, presenting to you, share the experience with you, and how do we realize this vision together. So besides that, we also have many exciting users in the conference today to share with you their journey to the data orchestration and what they have going through, what we have been going through, and what value they have seen towards the data orchestration, how they are building this into the future. With that, I just want to welcome you again. I want to thank you and enjoy the day. And hopefully, you will join the data orchestration community moving forward as well. Let's create the future together. Thank you very much.